All right, welcome to one of the last talks here on day one of UGM 2021. This is Mike Conway and D. Patel from the NIEHS, National Institute of Environmental Health Sciences in the US. And Mike's gonna tell us all about what they've been doing the last year or so, touching all the things. Take it away.
Thanks a lot, Terrell, and welcome everybody. I'm really glad to see all these familiar faces. I'm doing the talking, but Deep is here especially because he did the lion's share of this work, and I wanted to make sure that he was recognized. So, environmental health science, we're a division of NIH, and we are concerned with environmental exposures, toxicology, and how chemicals, how different kinds of exposures affect people's health. We use iRODS here at NIEHS for managing intramural research data. It's mostly sequencing data, so we're really happy to hear Sanger's talk this morning and to have them be a host, and we thank them for doing that. And we really are watching very closely what they are doing and hoping to take advantage of things that they learn. Here at NIH, we have a strategic plan for the entire NIH organization, and so we are very much trying to track that strategic plan. I wanted to highlight the sort of NIH aspect here. I came from the NSF side. I actually worked at RANSI and worked on the data nets, and I think that what's going on the NIH side and health science side is potentially really important to the iRODS community. And so one of the things I wanted to do was really just kind of elevate that. NIH, we've talked about things like Gen 3 and so forth, but you see a lot of the interactions with things like Gen 3, with what NIH is doing with their strategic plan, playing out in the GA4GH space. So we're trying to get involved with the cloud work stream, and we'll touch on that, but I really think here's an opportunity for the iRODS community. And I know there's others around the community who are already interacting with GA4GH. But we wanted to kind of talk about from going to, from like working on developing iRODS and developing CI to now doing, we have this expression, eating your own dog food. So now we are consumers of what we had previously been, building and developing and promoting. And so being on the outside, we can't really effectively, change the core server or sort of drive things that way. But what we found is that we can try to work on the real world problems that we have here at NIEHS and that we see in the community, focus on those and look at how can we look at our problems and come up with cheap and simple solutions that don't pollute the community code base. In other words, try to do things that are this plugin model that I'll talk about, and then try to see how we can reintroduce that into the community. And this is very much in the spirit of open source. For us, we want to develop sort of more usable tools and patterns and count later on maybe getting some fallback from efforts in the rest of the community and try to gain some critical mass for some of these things. So what I'm going to focus on today is adding microservices around core iRODS capabilities that can do some of these common tasks, and then see where we can align that with the strategies that people like Jason and Terrell are promoting and the capabilities. Microservice is a loaded term here, and here I'm talking about the new definition of microservices, which is really around small containerized RESTful components that do targeted functions. And I wanted to look at how some of these raw materials we're talking about lead towards some bigger fish that the community can tackle together. I really want to go back, and I really love that Raja was giving a talk, because I always want to point out iRODS roots, which was as a data preservation archival environment, really focused on the policy-based management of data. This is what really, I think, still distinguishes iRODS from every other solution. And as we kind of talk about this sort of connected multi-repository and cloud world that we're in, to try to think about how those core capabilities and that notion of policy really do provide sort of a unique place for iRODS. And to focus on iRODS as being this canonical store for data and metadata, and then you turn around and you leverage that for some of these outward facing tasks. So iRODS monitors and manages the data, and not just a plugin to talk to a storage technology, but it's about applying policy then through those plugins where you can to to like actively manage that data. And we wanted to talk about one of the big things now is indexing and leveraging existing search technology. We don't want to put that problem into the iRODS proper. We want to try to use capabilities to offload that to existing solutions. You're not going to build a better solution than Elasticsearch or a triple store or a graph database. And I want to start talking about iRODS as a data curation hub. So this is sort of an update of sort of the original archival preservation view of iRODS. And this notion of a curation bus is coming up over and over again as sort of a theme in this, as I call it, cloudy multi-repository world, which is the world that we're living in. So that's a bigger picture I want to get to, but I really want to break down into two like actual tangible pieces of capability and then build out. And the two pieces are search and indexing, and then file carts and publishing. We're not the first people to sort of touch on these things, but I wanted to try to put it in this sort of plug-in frame as a very practical thing. So we have this notion that there are plugins that are capabilities outside of iRODS. They have, these are typically containerized that have a REST endpoint, and they use JOTs to mediate security and just all the very typical things. And the plugins have a very simple architecture in general, which is the plugins advertise themselves through an info endpoint. And that's different depending on the sort of class of plugin you're looking at, but plugins advertise themselves and describe their capabilities, including the user guidance that you would want to present in some form to the user. And then they have an action endpoint to carry out a simple focused action. There's a trust relationship where the JOTs have claims that represent an iRODS identity or an identity that can be mapped to an iRODS user and their authorization. So with just those simple ingredients, we want to tackle two subjects here. And the first one is search. So what we wanted to do, because we've been using metalinks ourselves, and while not perfect, at least it's a sort of a beachhead that we can start on. And we wanted to like not focus on metalinks, but instead start focusing on these plugins around it and then add those plugin capabilities to metalinks. But they don't exist only for metalinks, and I'll get to that. So search, we wanted to, instead of building a heavyweight sort of search, rebuilding jQuery outside of iRODS or something like that, we just wanted to use this lightweight model and think instead of very cheap plugins, and think of organizing your plugins by the search persona or the very targeted task for which that search is going, that search is being carried out. Agnostic about the underlying search technology. So, I wanted to compare that to like the approach of Query Arrow, where instead just move that all outside of iRODS, and the only thing that iRODS would need to do, or iRODS clients would be to know how to interrogate the plugins for the info and then present, a search query in a simplified form. And we wanted to start with, since these things are narrowly targeted towards personas, that's really important because there are a lot of assumptions you can bake into the search plugin. So for example, I'll show you in a second, we have a search for our epigenomics core that can search for runs and samples based on the project information and information about the samples. So on the project level, it can be the hypothesis, the gene of interest, a pathway that's being targeted. On the sample level, it could be what preparation kit are you using? What is your reference genome? Who's the PI? When was this requested? Is it, what was the sequencing technology? Who was the technician? All of those things. So, if we have a question about, we had a problem with how we had the bisulfate flag set on these QA runs, we could interrogate for all the bisulfate runs that were done in a certain time period and get those for technical reasons. Or you could have, show me everything that we've done on mice and some sort of one particular chemical. So we wanted to have in that a user-friendly search string. Just type some text and then take that text and make some assumptions and translate that into the DSL appropriate for the particular search technology, whether it's a Sparkle query or an Elasticsearch query. So you start with the plugin that has some assumptions, where if I just type a string, in our case for the project and sample search, it'll look at the hypothesis, the sample name, et cetera. But also you could have attribute colon search terms so that you could have more specific queries like sample ID or index, or preparation kit or something. And then from that, we can also build it out later into builder interfaces where you're building queries interactively in some sort of GUI environment. And this does include things like ands and ors and grouping and things like that, wildcards. And then we wanted to have UI and API friendly output. So you can structure your results to look like a Google search result page with sublinks and so forth, or it can mimic ILS, LA listings, and that's important down the road. So here's just an example, the search API, and I'll have some links to where these things actually are. The search plugin has a get interface or a get endpoint where it tells it, here's my search schema, here's my purpose, here are the attributes I support. And then it has an execution method, which is the search, where you're passing just the search string in the form I was describing, and then the plugin itself will do the necessary translation to the underlying DSL. In the metalinks example, the way those info endpoints work here is like, if I do add pluggable search into metalinks, I just give a comma delimited list of the search endpoints, and it will automatically interrogate the available info endpoints and just dynamically discover what plugins are available for me. And that I can't really show our site. We're very sensitive about showing any kind of production website. So I took some screen caps, but this is an example. This is what you would see in production currently, where Metalinks has come up and it's discovered 3 plugins. There's an epigenomics projects, epigenomics samples and runs, and then there's a generic metadata search. This would be file properties and AVUs that maybe Terrell can highlight later. We're trying to merge this with the indexing capability of iRODS natively. This is what the endpoint looks like when it's describing the available attributes. So in this case, for the samples and runs, you can just see part of the analyst email or the date or the genome ref. These are things that you can put in these comma delimit or these colon delimited advanced search queries, whether they're done by entering in that text box or whether they're developed by a builder interface. So enter a plain string, make some assumptions based on the persona, run the query. You can do these advanced queries, like in this case, a particular genome ref and a particular preparation kit. It's and by default, but you can introduce ORs. And again, that attribute query style can support builder type queries. The options, there's sort of a structure. You can either get the option to display your search results in it comes back as JSON, but essentially mimicking what you would see in a Google search result, where you have a link and a title and a description, some sort of URL link. You can have subtitles. You can have properties underneath so that you can have bold, comma, attribute values as sort of represented in an interface as bold and a colon and then a content field. You can also have sublinks, which could be see also links or some other form. So we tried to make it generic enough so that in here, this is for our samples and runs search. So you can see there's it's scratched out, but there's a title with a direct link to a run folder. Underneath, you can see properties play out. So in this case, we're giving who prepared the library, who's the PI, and what kind of sequencing was it. And then you can see underneath how these links can play out. So when you search and you find a run, you also get links to the individual samples in that run, so you can go directly to it. But you could do any kind of see also links or anything else that's available in your particular index. Deep has also added grid style results. Now, like on Metalinks, we want to rip out that collection browser. It's not the best. And what we're trying to do, honestly, with the search is start in the search results area and then kind of take this and you could replace the collection listing with these search results. So this is a case, in our case, this is Vue.js and Metalinks, and it's a single page app, that is the current expectation. But the notion would be then that puts a saved query on an equal footing with a standard iRODS collection hierarchy. We'd actually done that already in iDrop Web, but the notion would be that I can do a search It can go against some search technology. I can save it as an iRODS collection, and then I can just click on it as a folder. So you sort of break the iRODS hierarchy and you can rearrange your data based on metadata. So that's actually very easy. It's actually very much available as a sort of a notion. The important thing about those things too is like that we wanted to make the search plugins so that they could return the same as an ILS LA listing. So you could have an ILS that would, instead of giving a parent folder, you could do an ILS and then give a saved query and use the I commands to navigate these queries. So, you know, virtual collections, that was the term we gave for these kinds of things where you're basically, you know, breaking the hierarchy and rearranging your data based on metadata. Search technology is really great because you can build a search index that can span federations or even two iRODS grids that are not federated. Another thing we added, it's in metalinks, but this notion we have here for fair data that metadata may be public, but the data itself may be private. So you can also have this notion of landing pages for an iRODS path that you don't have access to that would include, you know, buttons to request access. We're working slowly but surely with Terrell and crew to merge what we're doing with the plugin architecture of iRODS in the sense of the indexing capability. We are at NIEHS and we're working on this, building an index and a search plugin that will do file properties and AVUs so that you can do, you know, show me all files between these dates greater than the size of this MIME type that have these two AVUs, that sort of thing. We have an indexer we're running now. This is just a little thing. This is actually a really cool notion to have a visitor framework. So we're indexing based on a visitor framework. So it will just give you notifications when you're at a leaf or a node with the metadata stack from that node or leaf to all the way up to the root of the hierarchy above, stopping at each parent. So you can go through the metadata stack, and at each point I can get all the metadata of my follower collection and all the parent data, and then just plug in how I want to, for example, add that data to an Elasticsearch index. And I wanted to kind of make a plug for that and say that would be a really neat capability to have in the iRODS rule engine. The other thing we're doing is this file shopping cart, which sounds prosaic, but it actually I think is pretty powerful. This notion that now you can go into metalinks, pick files or collections, add them to a cart, which is really just a hidden file in an iRODS folder. But then the notion is when you go to the shopping cart, we have a different class of plugin, which are these publishing plugins. The notion is that publishing plugins operate on a cart, which is really a file manifest. And that's a really neat concept when you can think about what you could do with developing a manifest of files and then applying an action to that manifest. If you look at Gen 3 at the bottom of it, that's all that thing does is it creates an Elasticsearch index, you do faceted browsing, and you create a file based on a cohort or something, and then you take that file and you download it as a manifest, and you do a thing with it, or hand it off to Jupyter Notebooks or R or a workflow. So think about what you could do if you had a standard notion of a manifest of iRODS files and actions you could apply to it. And so that's sort of in here, and we're playing with that now. Again, the publishing plugins, they advertise themselves through an info endpoint. They're simple, but they can do complex tasks. So a publishing plugin, when you execute it, has a couple of options. It will tell you what kind of plugin it is, but you could do a publication that just returns a notification. That could be in a user feedback box or something. You could run a publishing action and it would return a download to the, you know, in a web interface, you would just, a file would download after you did the publication. And that's what we're doing now. You could have it where the publishing would respond with an iRODS absolute path that you could do something with. So I publish something, it's actually just creating a tar or a zip and putting it in a location in iRODS and then giving me that location would be an example. But you could also have a publication that would return with a link to an external site to complete the action. And we'll kind of talk about why that's really important and powerful. So think of them as having like a plugin might have different behaviors. Our current scenario is for gene expression omnibus, because when we do sequencing, we want to take those sequencing data and provide them to Geo as a specialized repository along with a very specific metadata in a specific format. So currently what we're doing is we can go through now and pick FASTQ files or runs, and then mine all the data in our commons and emit the spreadsheet that is used for Geo, which has all the files and all their checksums and you know, what's the tissue type and all the things that we keep. And this is being rolled out to our core now in this first form. The second step would be that the publishing plugin would also find all those FASTQ files, gather them all together in one place with that spreadsheet data, and put them in a location on DDN where the researcher can then pick them up and do the thing with them. And I think they'll love that. And then the final step would be what we're really trying to get to, which is you do the publishing, it sends you to a link where you do the curation to fill the rest of the metadata that we don't have in our commons, like the files that go with the analysis. And what can happen then is it can do the Geo spreadsheet, it can get the files, it can push those files directly to Geo, server to server, and it can also capture some of that data at that point and put it back into our commons. So we can look at a run and we can say this was published to Geo and here are the accession numbers and so forth. So we're trying to get to there, but the publishing plugin, that model will serve that. And this is really the point I want to sort of get to, like to take some of those pieces and put it in this bigger context. So when I'm waving my hands about GA4GH and the NIH strategic plan, it really is to this sort of class of problems. And I really do think there's something here where iRODS and this community can really participate. So it's this question about where do I put my research data? That goes back to DFC, and before that it goes back to NARA and doing sort of traditional OAIS archival stuff. But the sort of game has changed, but the underlying capabilities are still there. So what I'm advocating for, and it's not something I've discovered, it's just something we've seen other people write about and we're struggling with ourselves, is this notion of a data submission bus. Because when we get data, it's not all going into one bucket. Instead, this part of the data is going to go to Geo, this data may go to dbGaP, this data may go to SRA, this data we may throw into Figshare. That's just the world we live in. And now we have this notion that a project has data now scattered in these targeted repositories, and then it's got the bits that don't fit anywhere over in Figshare or something, or a Dataverse. How do we have a central notion of these things? And so this is where iRODS, I think, can play a part. Because if you think about these capabilities of policy-based data management, and what iRODS' job is it is the canonical place where that metadata is validated, stored, and preserved. And then from that, you can use that as a tool to push this data out and yet maintain all the DOIs and accession numbers and sort of a central idea of where that data came from and how it relates to, for example, the data that came from an intramural lab. So the assembly and curation of data sets and metadata models push to these appropriate repositories, the DOIs and accession numbers coming back into the system through this sort of publishing notion. And in this is where things like metadata templates were really important, and it was kind of the genesis for some of this. Is you have a canonical repository, but then you can crosswalk that data into the target repositories. We're doing that now in the small with Geo, but I can see how that notion would play out. So I just wanted to sort of do it as sort of a story. So you have this data curation bus, which kind of aligns with these sort of data concierge services that people are starting to try to develop, and these sort of data coordination centers. And the other thing that's happening at NIH, as it has with NSF, are these data management plans. So think about the data management plan as sort of a wedge of policy that associates with this bus. It's not that fancy. It may just be you have to hard code some rules and things like that to carry out data management plans. But the notion would be that the data management plan is there, and then the bus is connected to all of these various storage technologies using the native things that Jason and Terrell and them have built over time here. I'm really pleased to see Globus because I could really see Globus playing a part as you have to tie in our case, extramural researchers that are on NIH grants or that are doing Superfund or something like that. They're in institutions. You could connect with Globus. You could go to their cloud data through S3. You could even federate where that's possible. The notion would be you have this bus, it can see the storage, you have these data management plans as inputs, and there are people in the loop. Somehow you need to be able to validate that you have the right canonical data in the right form for the domain you're working in. In our case, it would be toxicology and next gen sequencing, or microscopy, or the various domains. And then you have this capability of publishing to these targeted repositories like Geo, or these sort of generalized repositories like a Figshare or a Dataverse. And it's because you have this sort of mechanism and these policies in place, and you're doing this through this sort of publishing. The important thing is really this, which is getting that DOI and accession info back so that you all together. And then you can see how that naturally plays into the notion that the indexing capabilities and the search capabilities become more important, because you're not only searching the data that's between this iRODS and the storage plugins, but you're also now able to tie your research data across these multiple repositories. Because I think the world looks much more like this, and this is even beyond federation, in the sense that the way we talked about it in DFC, that was more iRODS to iRODS federation. This is really about how do you manage data that are in repositories that can't speak to each other any other way, other than being in the game as you do these sort of data coordination moves. So I just kind of wanted to throw that out there, and maybe that can be an interesting frame for thinking about the plugins, a lot of the plugins and capabilities that we already have. And we're not making this up. I don't know if Nirav is on the call, but Cyber UK did something called COPO that was really interesting, and was trying to attack this sort of problem. So I have a link here to an interesting paper on COPO, and I think that's a good mental model. It maps onto exactly what we're discovering ourselves. And also in the geoscience space, they were talking a lot about this Geo DARS workshop. The output of that was really about this notion of managing research data is now not just about a bucket where I can throw my things like an institutional level repository, but rather it's about sort of mediating between a whole network of specialized repositories like dbGaP and non-specialized repositories like a Dataverse or a Figshare. But this notion too that you need federated search across that. And you also need, authorization and those kinds of things. And so I'm going to kind of stop there because I see my timer is winding down. But I wanted to throw out like some specific things, and then that more general notion, and both a discussion on the life sciences GA4GH side and how that can maybe be advanced, as well as this notion of this data sort of curation bus. And now I'm going to shut up.
Oh, it's great. It spans a lot of different areas, and so we've got a couple comments and kind of claps in your general direction about being a hub and talking to external services. We should not try to solve all the world's problems. That's not reasonable, and nobody wants that. So I totally agree. I do think that the work for the indexing stuff, we can, now that we've got 429 out the door, and your geo work is, if it has a bow on it, I don't know, maybe the ribbon is being threaded, but we can sit down for a couple.
Yeah, the geo stuff is really specialized. It's really based on our data, but what is not specialized is just that general plugin notion.
Right.
So you could think about, I was gonna say, you could think about doing things like generating a manifest and then having a little language in Jupyter that you could take that manifest and now go to a Jupyter notebook and access your cart and do something with those files in your manifest. That's what Gen 3 does, Yeah. Yeah.
Okay. Well, I think, there's probably a couple days in our near future where we just knock this indexing thing out. because I think all the pieces are there. We just have to make them all line up. Very, very good. Thank you, sir. Right on time. Thank you, and thank you, Deep.
Thank you.
Appreciate it.